All right, hello and welcome to the LED notification system. Just as a grand overview of what we're trying to achieve with the system, the main goal is to communicate information from inside the submarine to the outside. So we will, for especially our I2C sensor board, have LEDs built into those, and those are separate from what we're doing here. For this system itself, we want to have a really visual way of seeing what's going on inside the submarine as a general, and as well as what's happening with the software. So there's two parts to this. First of all, we want to be able to read out data. We want to be able to see what systems are online, what systems are throwing errors, what the submarine is starting to do, etc., etc. And then the second part to it is that we want to be able to maybe even display our sponsorships and our sponsors, just having them go through the submarine or wrap around, whatever. So to achieve this, what we have been thinking of so far was to use a matrix of neopixel LEDs, so something that is probably 10 to 15 centimeters broad, and then can cover half of the hull. So it's basically curved around the hull, and it's just this matrix of LEDs. Important to note here is that we don't have to use the neopixel LEDs because those can be quite expensive, and rather use some other single addressable LEDs. But those will be mounted on a flexible PCB, which is then placed inside the hull and can display our sponsorships, our data, whatever, that we will either pass on to the sponsorship team, or if someone in this team is interested in embedded systems and coding for embedded systems, then obviously that's something you can do as well. For now, I think it is important that we find out if we want to use off-the-shelf flexible PCBs with a matrix of LEDs on them, or if we want to really do our own. Then I want to figure out if we want to use the NeoPixel LEDs, or if we want to use something along the lines of the WS series that are used in LED strips. And then we also need to figure out if we're going to run it at 5 volts or 12 volts or 24 volts even, which would then require us to boost the voltage as well, because our batteries only go up to 16.7 volts nominal, 16.2 volts nominal. I think that's pretty much it for the system. It's quite a simple system. It's not much that needs to be done there, but technically we need to figure out, even if we are going to print it on a flexible PCB, that would come with its own challenges. Now, a few teams that you do need to coordinate with is the electronics tray team, because they will have to design some way of mounting that actual PCB in there so we can remove it with the rest of the electronics tray. I also want you guys to communicate with the power supply team, or I guess as we're not redesigning the system itself, you will be limited to 12 volts at 3 amps max. Although we could see if we can step that up to 12 volts at 6 amps. If we give you two of the outputs of our current power distribution board, we can even put a second one in the hull, so that's not too big of a deal. Ideally stay below that, what is that, 72 watt limit, just because of heat dissipation as well. I'd also like to see that we minimize that heat dissipation, because we just don't want another source of heat in our hull. Yeah. And then for the design review on Thursday, again, I would like to have those questions I asked earlier answered, as well as a general approach to how dense we can make them, or if there's off-the-shelf components that we can use. Yeah, sounds good. Thank you guys.